Hi everyone, quick video here on what's known as geometric mean. So we have two types of mean. The one that you're probably familiar with is called arithmetic or arithmetic if you want to be really fancy about it. Mean, that's the one that you probably learned in like the 5th grade. Add up all the numbers you've got, divide by how many there are, you get the average, and we call that the mean. Geometric mean involves multiplications. Actually very simple, except for the fact we have to work with radicals. The geometric mean of two numbers is the square root of their product. So all we have to do if we have two numbers a and b, when they say the square root of their product, we take their product, a times b, and square root that number. So for examples, 3 and 5, I would have the square root of 3 times 5, which is the square root of 15. I can leave it in radical form, or I can make it into a decimal, depending on what I'm being asked to do. 2 and 8, I would do the square root of 2 times 8, which is the square root of 16, which is 4. And when you're using geometric mean, you usually, asterisk, there could be a reason where you wouldn't, but 99.9% of the time, you're going to use the positive square root, okay? And then the last one, I just want to show you this one, 9 and 2. That's the square root of 18. 15 can't be simplified anymore in our first example, but 18 can because it's 9 and 2. And we know there are two 3's inside the 9. So that is 3 root 2. So geometric mean can and should be put in, like I said, if it doesn't reduce to an integer, you can leave it in radical form if it is simplified, or simplify it like we did to 3 root 2, or calculator and use the decimal approximation. There is one more version of geometric mean that we see in applications, and that's in a right triangle with altitude to the hypotenuse. So the altitude, remember, is a segment that connects a vertex, like A, to the opposite side in a way that makes a right angle. So this is altitude to the hypotenuse, and actually I'll call that D so that we know that. So AD is the altitude to the hypotenuse. And so we have a couple formulas. So we can say that the altitude itself, that has the value h, is equal to the geometric mean of the two pieces of the hypotenuse together. So I'm going to trace over those. N times m. We can say that in terms of this hypotenuse, we can say that if I take, or I should be able to find, maybe that would be the better way to say it, the sides, the legs, are equal to the geometric mean between the part of the hypotenuse that's adjacent to that leg. So if I have B, if I have this leg, the part that's adjacent to B would be M, and then the whole hypotenuse, which they're calling A, little a. Okay? And then I can say the same for the other leg. So C is equal to the geometric mean between N and the whole hypotenuse A. Right? And those are just formulas. You might see, I've seen teachers show students things with like squares and strange looking formulas so that you don't have to deal with the radical. In my opinion, these three formulas are the easiest versions of this to remember. So I always show it this way, and what I tell students is whatever information you're given, put in what you know. You know how to solve an equation with a square root in it. If you got to get something out from under there, just square both sides and do what you need to do. So that's the easiest thing to remember. And that's really all there is for geometric mean. So remember, geometric mean is the square root of the product of two numbers. And then we have these three formulas, and that is again specific to altitude to the hypotenuse in a right triangle.